want to go ahead and talk about this example. Again, we can solve anything you will see in this course without going through the formal process of assigning oxidation numbers. However, if you would like to do that, please feel free to do so if that seems simpler to you. Instead of giving formal numbers like plus 1, plus 2, plus 3, minus 1, minus 2, minus 3, we're just going to think about, does something have more or less electrons if there appears to be some sharing going on? I'm going to start with these things that are kind of by themselves. So the zinc and the hydrogen are just zinc and hydrogen. So they are going to have exactly the number of electrons that you would expect based on the periodic table. There's really no change from that. Within the hydrogen, because they are both hydrogen atoms, even though there are two of them, there's no reason why one of those has more of the electrons than the other one does. Then we're going to look at the compounds and see what's going on there. So we've got, I'm going to start with this one. I know it's the second one, but it's also the most obvious, I think. So we'll start with the more obvious one. So in this case, we have a metal and nonmetal, and what we know is that when we have a metal and nonmetal together, the metal will lose electrons, and the nonmetal will gain electrons. So we're going to expect, we don't necessarily know exactly what, we could figure out exactly actually what the charge is, but we would expect this to have a positive charge and this to have a negative charge. We don't have to know how much for what we're doing today. You could probably figure out how much, but we generally can say, okay, the metal has less electrons than nonmetal has more electrons. We can do the same thing with this other compound. Now, in this case, we don't have an ionic compound. We have, this is an acid. For the acid, we're going to do something similar. So remember for an acid that we have something that will lose a proton, which is an H plus. So we might imagine that the hydrogen has lost an electron here. If that's a plus, this one is a minus, okay? So not exactly an ionic compound, but the same principle applies that we had over here. So something with fewer electrons, something with more electrons than when they were by themselves. This is very similar to the process we would use when assigning formal oxidation numbers. The difference here is that we don't have to get into all of the edge cases of, say, what if the chlorine has some electrons but it gains even more? Or what if it's lost some electrons but it loses even more? We're just looking at situations where one of the substances will be in its elemental state, okay? So zinc in its elemental state, hydrogen in its elemental state. So we're just looking at changes involving elemental states for this course. So that's a little bit of how it's different and a bit simpler than what you would do with formal oxidation numbers. But again, if you would prefer to do that, please go ahead and do so. Just realize we're kind of cutting out a lot of edge cases by focusing essentially on reactions in which we have an element by itself. So for the zinc, we go from regular zinc to zinc that has lost some electrons to gain a positive charge. So it has lost electrons, so that is an oxidation. For the hydrogen, we go from a hydrogen that has missing electrons to a hydrogen that's regular hydrogen with its regular amount of electrons. So that is what is reduced. We also have the chlorine. So chlorine isn't really changing here. It has more electrons than normal here, more electrons than normal here. So it is not involved in either oxidation or reduction. So the answer to this question, oxidized, is going to be the zinc. The zinc is oxidized in this reaction, and then reduced is going to be the hydrogen. For the examples we'll see in this class, everything will be involving something in its elemental state. And so essentially what we're looking at is, are we changing the elemental state in a way that is losing electrons, or are we changing the elemental state or to the elemental state in a way that is gaining electrons? So that's kind of the limitations of what we'll be looking at in the scope of this course.